Happy. Okay, I think I'm recording. We'll find out. Okay, so here's what I wanted to look at here first. Blah, 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 blah. Nobody's listening. Nobody cares. Lucas is back there just holding court. Which one? He still has not stopped walking around. Why are you coming up here again? Okay, just go get your stuff and go. All right. Just, anyone else want to leave? Me? Right. Okay. Hey, you know why this happened? You know why this happened? You know why this happened? Oh, this one's not the same angle measures here. So, but these two were, and you end up getting one. You know why? It's an identity. Then look at this. Sine of 11 pi over 6 over cosine of 11 pi over 6 gets you this. So does tan. Why? This is an identity. Same thing with, well, I think we have a tan of, did he really leave? All right. I don't know if I was supposed to sign that sheet. And then you know why this works? Because this is an identity. Okay. 1 plus tangent squared equals secant squared. And then why did they what the heck did they do here? Yeah, I don't know why they have this one here. Did they change that to 11 pi over 6 on your sheet? Yeah. I don't know what they're comparing that to, but guess what 1 plus cotangent squared equals cosecant squared is? And identity. Okay, so here we go. That's what the connections were there. No idea if we're recording or not. We'll find out in the end, or if it will allow me to have a video. Love you, we video. Anyway, maybe this is why the videos don't work. They hear me saying these things on their little. Oh, what the heck! I'm getting a phone call. Oh no, it's my daughter. Do I answer this during class? This is awkward. I'm in class right now, but yes. And I'm actually recording my note video, and you're on the recording right now. So, what's up? No, you're scaring the heck out of me, though. No, he's with the other person. I'm just kidding. Yeah. Okay. You going to the eye doctor? Okay. Good luck with that. You're paying for it though, right? I don't. I'm just kidding. I'll see you. All right. Bye. Okay. So reciprocal. What does reciprocal mean? Flip, 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 flip. You can write this in many different ways, and you can reverse this. Who's a hoe? What? Okay. Sine is so, cosecant's a hoe. It's a little joke we do in class. No one get offended. Okay. Cosine of theta equals 1 over secant. We know this, right? And then you could reverse these. You could, hey, da 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 da, to get Triggy with the video switching. I think some of you guys are fractionally challenged in this class. Okay, not as much as my other classes, but Mr. Bean complains about this. Physics teacher, I almost said chemistry. Negative angle measures. Okay, you can count the brothers or sisters having the same identity as this. So what I mean by that is cosecant of negative theta is negative cosecant theta. And then the other one is tan of negative theta equals negative tan theta. And it's because these functions are odd. Sometimes these are called the even odd identities. I'll change colors because cosine is even, which means it has y-axis symmetry. So this is called an even function. So sometimes we call these identities the even odd identities. They are called that in our old trig book there. And then I already broke this down for you. Whoa, whoa, whoa. What I did is I put x squared plus y squared equals r squared, That's x, that's y, that's r. We can use the Pythagorean theorem to find any of those missing sides if we ever had a, well, we had that too before. We gave you a coordinate that where a terminal ray passed through and you had to find like all 6 trig functions. So we've seen this up. If we okay over there? How's that come back there? Good? Both of you. All right? Used to be illegal back in the day. Hey, when I divide by r squared, what's r squared over r squared? 1. What's x over r? What's x over r? Which trig function? Cosine squared. I broke this down why it ended up being cosine squared of theta. I did it in previous notes. And then what's y over r? Sine squared. Not writing this very efficiently here. And you barely have any space, do you? Right? Hey, and then maybe just for colors, let's get rid of that and let's divide by, oh, let's go y squared. Divide by one of the 3 letters and then you'll know exactly what the identities are. So what's y over y? That's 1. What trig function is x over y? Not tix. That's y over x. So what is it? Cotan. And then what is r over y? No time. I can't wait for your non-answers. Cosecant. And then let's go purple. Bless you. X squared. What's x squared over x squared? 1. What's y over x? I just said it. Tix. And then this is so easy to derive if you don't remember these. What's r over x? Secant. And then what does it mean for quotient identities? Quotient means division statement. So that's kind of deceptive, you know. What it really mean is quotient of 2 different trig functions. That was the one that was proven on the sheet from yesterday. Tan does evaluate and equal sine over cosine. And then cotan equals cosine over sine. All right, got it? And then here's what this is. This is just, you know what this is? Put this word up at the top. Anyone? Substitution is really, am I spelling this right? Substitution. This is really what you're going to do. And then what ends up happening is you end up, in many cases, it ends up being simplified forms when you do some substitution. Okay, so you're going to use these identities, substitute them in, and then you're going to see that less is. Are you guys okay? Every time I look over there, are you all right back there? No, but what do you get that computer out for? Oh, do you have the code? Oh, that's right. Wait a minute, something's wrong. Is he supposed to have the calculator? No. Okay, you're cheating. Hold on, we have an incident. We gotta arrest somebody. All right, you're not supposed to have the calculator on the computer. Yeah, give me. What are you doing? Wait, did you do this yet? Oh, you got. What number are you on? Oh, okay. Finish that. Okay. Oh my goodness. Tell everyone what just happened. What kind of pencil is that? No, it's this one. We have 2 pencils. They named it after that one. They go like this. Oh, which one? This one. Okay. Wait a minute. Did you steal that pencil from up here? You just stole this pencil. Who is this person? Do you guys know this guy? All right. All right. Anyway. Okay, you give him that calculator back, then you can pick up your computer. All right, so get that written done. What? I can't hear what you're saying. Okay, all right, so here we go. What's cotangent, everyone? What's cotangent? What's cotangent? Cosine. You know what's best a lot of times is put everything in terms of sine and cosine. Why? Because then you're going to see some things cancel. Right, so we're getting them like, it's like saying we're getting them in the same variable in a way. And then cosecant's 1 over sine. Now you guys should be able to figure this out. Who cancels? Well, there's only one. But they do because they're both in the denominator. But this is what I'll have to do with the ABers. Hi, class. We're going to teach fractions from 5th grade again. All right. And then dividing by 1 over sine is timesing sine over 1. That's what this does. That's what happens. That's how division turns into multiplication. Yeah. And then those cancel. And then that is simplified. That is smaller than that, right? Okay, that's simplified. Some of these don't work out so great. This one's going to be great. Okay, now and I'll tell you what I mean by that. That's why I feel like in some of your homework I want to get rid of it. And actually, when you flip your sheet over, Isn't the first side like matching? Those are better because you actually can do a couple things, and it's maybe not necessarily simplified, but you can find a matched answer to it, and it may not necessarily be smaller. I'll show you what I mean by that. That's why these are good. These kind of questions right here are good for matching questions. This will get a little bit better when we do what's called proving an identity. You guys remember doing sorry, the brain's not working on a Thursday. Geometric proofs. Did you guys ever do those? Statement, reason, and it had to have logic, right? You're going to have that structure back, and we are going to have it. But it's not as bad as a geometric proof, but you do have to have logic steps, and you can't skip any. All right, so the logic must all be good. Who cancels? Who cancels? Cosine. What's sine? Sine everywhere. Sine. Do this, don't do that. Can't you read the sign? The answer was sine squared. Anyone know that song? It's an anti-establishment song. And then what's 1 minus sine squared, everyone? It is cosine squared. And now it's time to go back to the identities. It's time to go back to these trig identities. You must certainly be ready for alternate forms of all of these trig identities. For instance, in purple, what is tan squared equal to? What is tan squared equal to all by itself? Come on, that's not hard. Just reshuffle it. That's secant squared minus 1. And then we just showed you what 1 minus sine squared is. That's cosine squared all by itself. So when I isolate cosine squared, I'd have to subtract sine squared. You don't have to write them down and then memorize that portion. Memorize the top ones and then just know things can float. In green, here's an interesting question. Well, not really, but what's 1 equal to? This is so weird. In green, what's 1 equal to? What's 1 equal to? Cosecant squared what? Cosecant squared theta minus, all I did was minus cotangent. Fine, I'll write one more. That's a nice one. I could have done the same thing with the purple. This is what's going to happen a lot. You're going to get a lot of 1s with the trig identities. Okay? So it's just going to be, and then don't you agree this is simpler, smaller than this? Yes? Yes. Okay, it's not always going to happen. I like this one. We just saw this up here. Whenever I see squareds, though, try a Pythagorean identity. Leave that sine squared alone. I know that's 1 minus cosine squared. Why do I don't want to make it bigger. When I simplify, I want to make it what? Smaller. Okay, so yeah, people do goofy stuff. They do truthful things, but they're not simplifying. They're making it larger. Okay, what is 1 plus tangent squared? What does that answer? What just happened? Secant squared. That wasn't UE video. That was my other thing. This is weird. What is secant squared then? So I can make this like, I know what, I can already see what's going to happen. What is secant squared? 1 over cos. Why would I want to do that? What's 1 over cosine squared times sine? That is going to end up being sine over cosine squared, which is tan squared. And I do like this structure here, how I went, just in the future, you are going to have to step it out, and it's going to have to be logical steps that make sense as you make changes in each step. And you can do 2 changes in one. I don't think you have to write sine squared over cosine squared as step 3, then make it tan squared. Do understand sine squared over cosine squared does equal tan squared. Some people have problems with the powers. If it was sine cubed over cosine cubed, it'd be tan cubed, so on and so on and so forth. This one's stupid. Put it right there. Put it there. Put that word. Okay, and this is why I disagree that this is simplifying, and I disagree that anyone would think about doing this. But when we have a question later, let's see. Yeah, kind of a related example 5, but we don't have a bad one yet. When we're adding fractions, you're going to want to know this tool. Okay, what can I multiply the denominator by? Anything, as long as I say it. Multiply the numerator by this. Why in the world would I pick this? In the future, you might need this if there was another fraction and we had to get common denominators. What don't really think happens here is anything special. This does not simplify the matter. So I don't really agree with this being in our simplify section. But it is a nice math tool because what's 1 plus sign times 1 minus sign? What do we end up with? 1. Anyone? Come on, be good foilers and do your canceling. 1 minus sine squared. And then what is 1 minus sine squared? It is cosine squared. This is why I call this one kind of stupid, because I have a limited vocab. So I say these words, not besmirching any other person for having this on here. I would never do such a thing. See, but then a cosine would cancel. And then is this really simpler than what I started with? No. And just because the denominator has one thing instead of two doesn't make it simpler. There's still 3 things. Just 2 of them happen to be in the numerator. That's why I said this. This doesn't simplify. I just changed it into something else and it didn't become smaller. I do, though, like this tool. Okay, so you have to see if I see like a 1 plus cosine. I can multiply by 1 minus cosine, and then I'll end up with 1 minus cosine squared, which is sine squared. And then if I have another fraction with it, I could probably get a common denominator that way. So it is a good structure mathematically. It just doesn't simplify. I don't really agree with it. All right, and this is what I mean about that. Well, this is interesting. How do you add fractions? What did your 4th grade Mrs. Krabappel say? Get a common denominator. If this was a 2 and this was a 3, what did Mrs. Krabappel say you had to multiply this by? Multiply by 3 and this one by 2. Good yawn over there. All right, so what do I multiply the top and bottom of this one by? Cosine. But I got to do the top. And then what do I got to multiply this one by? Sine. But I got to multiply the top. So when we have this is where it becomes, useful. And something like this will happen on a question like this. You'll have this plus another fraction, and then you are going to want to be able to do this. So that's why I was thinking of crossing this off because I don't like those questions per se in a simplified section. You do have to distribute. Sorry, his brain was not working there. And then I don't know why I'm writing cosine first. It doesn't really matter. Cosine, sine. Interesting. This is where we can do 2 things in one. Good thing this is plus. If it was minus, we'd have to distribute a minus sign. What is this? You just get out. Unbelievable. I'm telling your teacher this has been unbelievable. Go ahead, get out. You're on the list. You're on the list. That's another quarter, by the way. Did he leave yet? Do you know this kid? Do you know this kid? Do you or don't you? You do. I feel like this is illegal too. There could be answers on the toilet paper from his friend in the bathroom. All right, and then this is cosine. What's the matter? What, you have something to say? You know what I like doing too? I like doing this. Just least LCD or just a blah, blah, blah. You know, I don't feel like writing it. And sometimes I just go like this. So I know I'm not going to do anything to denominator it. I know I have a denominator there. I just don't feel like writing it. That's okay. I'm okay with that. All right. And then what happens? Cancel, right? That's like XY and negative XY, correct? Everyone okay with that? Okay, these are it doesn't cancel like this either. The cosines and then the sines. No, this is one whole unit cancels with that whole unit because one's positive, one's negative. They're the exact same thing, except opposites. And then this happens, right? That's why I did two things at once, but I could still see the logic behind the student. They changed cotangent and put a sign next to it and then crossed them off. And then they crossed off these opposites. So then the next thing would be 2 cosine theta. That's what cosine plus cosine is. And then this is cosine sine. And now, oh my gosh, I forgot. You know what? This makes me sick. Oh, the people that do this. Let's erase this real quick. Is this legal? Can I cancel those signs? It's time for this error. Those that had me last year, and I actually did do this year. 6 over 5. What's 6? Isn't that 5 plus 1? Just tell me yes or no. Yes. And then over 5. Hey, let's cancel those 5s. 1 plus 1 is 2. 2 over 1. So apparently 6 over 5 equals 2. True or false? False. I'm okay. That's like canceling those and canceling those in that step. That is completely and totally illegal mathematically unless you want to make up a new math that nobody's going to buy. Nobody. All right? False, false, false. Drink time. Is Tyler asleep yet or no? But can I cancel those cosines? Yes or no? Yes, I can. I can. Lockport. Hey, by the way, what's 2 over sine? What's 1 over sine become? So it could be 2 over sine or 2 cosecant thrown up to the numerator. Don't worry, I'm okay. No one really cares. Someone's just looking at me like, oh, is he going to die? Oh, then we can have 30 minutes off. That's what the kids are these days. All right. So good. Everyone okay? I'm fine. Don't worry about it. Okay. This is a strange one. Are you still on what are you doing? You're still on the calculator part, right? You don't get this extra time. You chose to leave. All right. All right. What's sine squared minus 1? What does that factor to become, everyone? That's just like x squared minus 1, which turns into what? X minus 1, x plus 1, right? 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 I also could have, that also is a Pythagorean identity. I'm wondering if that would be helpful. What would be sine squared minus 1? What would that be? That'd be a negative cosine squared. I'm wondering if that would have helped. But you know what? It doesn't because I could see I'm not done yet. I know you people, you just wanted to say something. I was thinking out loud. And then what do we do here? Take out a tan. Take out a tan. And then, there you go. There's sine theta minus 1. Now, that binomial is when they are exactly the same. They do cancel. Got it? Hey, you want to get nuts? I don't know if this is necessarily simplifying, but it is. I have a tan on the bottom. So what does that become up at the top? What does that become? Okay, I'm going to put a little blank there. What is that blank filled in with? Co, co, tangent. Tan on the bottom becomes cotan on the top. That's flipping. Got it? Flipping. And then when I throw this through, this is where we got to show that I know that that's cotan up on the top. When I distribute it, then I will change it to cosine over sine times sine. And then, you know what? I'm going to go back to just making this cotangent because there's no value in making it cosine over sine in the second part. So if I'm not doing too much, that's why I'm stopping, looking at the faces out there, making sure everyone's okay, making sure Tyler's up. And then who cancels? So, first of all, you do have to admit that that's better than the beginning. If you wrote cotan as cosine over sine, that'd be fine. You have to admit that this is better than the beginning, way smaller. Is it better than sine plus 1 over tan? Maybe a little bit, because that has 3 parts, 2 in the numerator, 1 in the denominator. So I guess there is an argument for that. What I did continuing this on. Definitely got to love the sine squared or sine theta minus 1 canceled. Okay, this is why this is good for matching. This will be nice and easy. What's 1 minus sine to the 4th? That's just like 1 minus x to the 4th, which is 1 minus, anyone? X squared, so sine squared. And then 1 plus sine squared. Wonder if I'd mark you wrong for directly canceling one of these with cosine squared. Which one would cancel with cosine squared? Which one would cancel with cosine squared? The first one. This is equal to cosine squared. If you wanted to do this and then go like that. And then unfortunately, 1 plus sine squared can't, that's not any form of the Pythagorean identity. 1 minus sine squared equals cosine squared. 1 plus sine squared, I'd have to plug in sine squared is equal to 1 minus cosine squared, so it would just be 2 minus cosine squared. That doesn't do anything, right? So that's it. Okay, but it is smaller, right? You have no more fraction, correct? It is better. Wouldn't you agree? No one said a word. Good whats are good whats? Because this is a FOIL, my silly little friends. Sine squared. Sine times cosine twice. Cosine squared. Then that random arbitrary minus 1 at the end. 4 sine cosine. Now I'd appreciate this. Commutative property is a word I used yesterday. And the commutative properties of addition says I can move these additions around. But I also could grab a highlighter to highlight the commutative property and just concentrate on those two. What's sine squared plus cosine squared equal to, everybody? 1. And I'm going to put a highlight there for that 1 plus 2 sine theta cosine theta minus 1. What's going to happen there? Not feel free. I need you to write those and not do too many steps in one, so I can cancel those. Then I guess I'm allowed to do the rest. What's 2 over 4? What's 2 over 4? 1 over 2. And then what's sine over sine and cosine over cosine? Cancel. No one in their right mind could argue that that's not better than the original, right? There you go. Is that it? Let's see if the video works. I don't even know how to turn it off. Seems like, oh, there it is.